Tesla just activated a $15,000 electric car that engineers claim will survive 250,000 miles, longer than most gas vehicles ever reach. The Model 2 Senior Edition isn't using magic. It's built by a 55,000-ton machine that replaces 300 welded parts with one single aluminum casting. No weld joints means no rust points, no failure zones, no gradual weakening over time. While Detroit still stamps and welds 400 separate pieces per car, Tesla finishes an entire underbody in 7 seconds. Is this really the end of traditional car manufacturing? Step into Giga, Texas today, and you'll witness something the automotive industry spent a century believing was impossible. A 420-ton machine standing 20 meters tall is completing entire vehicle underbodies in 7 seconds flat. Not 7 minutes, 7 seconds. To understand why this matters, you need to see what happens in a traditional factory first. Ford's F-150 line takes 90 minutes just to assemble the body structure. Workers and robots coordinate across dozens of stations, stamping individual panels, transporting them through the facility, then welding them together with precision that took decades to perfect. GM's Ultium platform, their flagship EV technology, still requires 30 hours from stamped parts to finished chassis. These aren't inefficient processes. They represent the absolute peak of conventional manufacturing refined over generations. Tesla's 55,000-ton Gigapress just made all of it obsolete. The numbers sound impossible until you see the engineering. This machine generates 110 million pounds of clamping force. The industry standard until 2024 was 18 million pounds. Tesla didn't improve the existing technology. They jumped to a completely different category of industrial capability, operating at forces 5 times higher than anything legacy automakers currently use. Inside this monster, molten aluminum heated to 1,300 degrees Fahrenheit gets injected at 15,000 psi through dual hydraulic circuits. The pressure alone exceeds what's needed to crush a standard car engine block into powder. What makes this revolutionary isn't just the force, it's what happens next. The entire casting cools from 400 degrees Celsius to 50 degrees Celsius in seconds, using aerospace-grade servo hydraulics borrowed directly from SpaceX rocket manufacturing. This is where Tesla's vertical integration becomes a competitive weapon nobody else can replicate. While competitors buy components from suppliers, Tesla develops technology across multiple industries simultaneously. The cooling system in this press uses the same principles that prevent Raptor engines from melting during rocket launches. Automotive companies don't have rocket divisions. Tesla does. The result is a single-piece underbody weighing 300 pounds that replaces what traditional manufacturing builds from 70 separate stamped parts, joined with 1,600 individual welds. Each weld represents a future failure point. When metal pieces are joined through welding, you create stress concentration zones that flex microscopically under normal driving conditions. Hit a pothole at 60 miles per hour, and those joints absorb force differently than the surrounding material. Over 100,000 miles, those micro movements become micro cracks. By 150,000 miles, you start hearing rattles, feeling vibrations through the steering wheel, noticing doors that don't close quite right anymore. The frame is literally disintegrating at a molecular level. Tesla's approach eliminates this degradation entirely because there are no joints to fail. The casting uses vacuum-assisted injection that pulls air bubbles down to 0.001% void ratio. Previous generation presses from 2020 achieved 0.5% voids, which doesn't sound significant until you understand those tiny air pockets weaken the structure by 15%. They're invisible during production, but show up years later as frame fatigue. By reducing voids to nearly zero, Tesla creates aluminum with 45,000 psi yield strength, 28% stronger than traditional multi-part welds, maxing out at 35,000 psi. This means the Model 2 Senior can meet 5-star crash safety standards while weighing significantly less, which extends range and allows smaller, cheaper batteries. The automotive industry operates on razor-thin margins, where saving $50 per vehicle determines whether a model succeeds or gets canceled. Tesla's Gigapress doesn't save $50. It saves $800 per vehicle before the first battery cell gets installed, and that number comes directly from comparing production data against traditional manufacturing costs. Traditional welding tooling costs $2.3 to $3.4 million per 100,000 units, plus 40 labor hours per chassis. Tesla's Gigapress requires a $6 million upfront investment with $1.2 million in tooling costs, but only 10 hours total per vehicle. That's a 40% reduction in direct manufacturing costs. Multiply that across 520,000 planned annual units, and you're looking at $416 million in savings just from labor and tooling. But the real devastation comes from material costs and supply chain simplification. Conventional chassis manufacturing requires 1.2 tons of steel sourced from approximately 50 different suppliers scattered across multiple countries. Coordinating deliveries, managing quality control across dozens of vendors, dealing with shipping delays creates logistical complexity, costing automakers hundreds of millions annually. Tesla's Gigapress uses 0.88 tons of aluminum from 5 suppliers, all strategically located near gigafactories. The company's Q3 2025 report documented a 25% reduction in freight costs, translating to $450 million saved annually. That money goes directly into making the car cheaper while maintaining profit margins competitors cannot match. Energy consumption reveals another insurmountable gap. A machine generating 110 million pounds of force should draw 20 to 24 megawatts per cycle. Tesla engineered a regenerative hydraulic system that recaptures kinetic energy, bringing consumption down to 11 megawatts. Over 10,000 daily cycles, that difference compounds into millions in annual electricity savings. Legacy automakers running traditional lines are burning double the energy while producing half the output. This is where the situation becomes genuinely catastrophic for established manufacturers. Industry analysts estimate that replicating Tesla's system would require $200 to $300 million in capital investment and 3 to 5 years of development time. GM just announced they're testing 30,000-ton presses for their 2026 EV lines. They're 18 months behind and operating at barely half of Tesla's clamping force, which means they can't achieve the same single-piece castings. They'll still need multiple parts and welds, which means they can't match Tesla's cost structure. The production capacity difference is equally brutal. Tesla can produce 450,000 underbodies annually from a single press running 20-hour shifts. Ford's best EV platform peaks at 200,000 units per year. Toyota's line produces 45 bodies per hour. Tesla targets 100 per hour. This isn't a competitive advantage that gets neutralized over time. It's a structural monopoly that compounds as Tesla's manufacturing expertise deepens while competitors scramble to catch up. The Chevy Bolt at $26,595 looked competitive 6 months ago. Against a $14,999 Model 2 Senior with superior range, faster charging, and longer structural lifespan, it's not even in the same category anymore. Tesla's engineering team analyzed 5 years of niche accident data and discovered something critical. Drivers over 65 have 40% fewer high-speed highway collisions, but experience 300% more parking lot impacts, door angle accidents, and mobility-related injuries during vehicle entry and exit. Traditional automakers saw these statistics and did nothing because they designed cars for crash tests, not real-world usage patterns of aging populations. Tesla built an entire vehicle platform around solving these specific problems. The challenge with senior-focused design is precision consistency. When you're engineering door counterweights, hinge torque, and grab handle positioning for people who may have reduced grip strength or balance issues, variance kills functionality. Traditional multi-piece frames have dimensional tolerances up to 3 millimeters across production batches. That's enough variance to make doors feel different from vehicle to vehicle. Some close smoothly, others require extra force. Some hinges sag after 50,000 miles. Seniors need predictability, and welded frames cannot deliver it. Every Gigapress casting is identical within 0.1 millimeter tolerance because it's formed in a single, controlled process. This consistency allows Tesla to calibrate door operation, knowing the geometry won't shift across 520,000 units. The result is wider door openings without sacrificing structural rigidity, critical for drivers who need more space or who rely on the doorframe for stability when standing. It also eliminates lateral torsion when someone leans heavily on the door, which causes door sag in traditional vehicles. Tesla's internal testing shows that even after 150,000 miles, Model 2 senior doors close with the same alignment and force as day one. Repair costs demonstrate another massive advantage for seniors on fixed incomes. Traditional underbody damage from a 30-mile-per-hour parking lot collision averages $1,800 in repair costs because mechanics have to cut out damaged sections and weld in replacements. With modular Giga cast construction, damaged sections get swapped entirely, bringing costs down to $600 with 50% less shop time. For someone living on Social Security who can't afford surprise bills, this difference determines whether they can keep driving or lose independence. Maintenance costs collapse for similar reasons. No weld joints means no rust points developing from road salt or coastal humidity. No multi-piece assembly means no alignment drift requiring periodic suspension adjustments. Tesla's fleet telemetry data from 2025 shows 98.7% uptime compared to 92% for competing EVs. Over 10 years of ownership, that 6.7% difference represents dozens of avoided shop visits and thousands in prevented repairs. The 300-mile range matters because it eliminates charging anxiety. At 12 cents per kilowatt hour for home charging, those 300 miles cost $6.36 versus $45 in gasoline for a Honda Civic. Over 12,000 annual miles, that's $1,320 in annual fuel savings. While media focuses on Tesla's competition with Ford and GM, the real carnage is occurring in the supplier network employing over 200,000 workers across Michigan. These companies manufacture stamping dies, welding robots, frame alignment jigs specifically for multi-piece chassis assembly. Tesla's Gigapress eliminates entire categories of equipment. When your largest customers suddenly need 60% less of your products, you don't adapt. You contract. Union leadership understands what's coming, which explains why UAW has been uncharacteristically quiet about Tesla's Texas expansion. Material suppliers face their own crisis. Tesla's modified aluminum alloy isn't commercially available. It was developed with SpaceX metallurgists specifically for extreme pressure applications. Competitors can't purchase it. They have to engineer equivalent alloys from scratch, a process that consumed 3 years between Tesla and SpaceX. Every month competitors spend in research is another month Tesla sells unchallenged while building production capacity competitors will never match. Insurance companies are recalculating entire risk models because vehicles with unified aluminum underbodies show 20% fewer long-term structural claims. Lower claims translate to lower premiums. Tesla already offers data-driven policies, cutting annual costs by $300. For seniors comparing ownership expenses, a $15,000 purchase price plus $300 in annual insurance savings versus a $27,000 Bolt with standard rates isn't difficult math. The final element nobody discusses is how this technology becomes more valuable as production scales. Traditional manufacturing achieves marginal cost reductions through volume. Giga casting gets exponentially more efficient because the press runs continuously, material costs decrease with bulk contracts, and quality improves as AI monitoring learns from millions of cycles. Tesla's per-vehicle cost will decrease as production ramps, while competitors' costs stay flat or rise with inflation. This is why legacy automakers are legitimately terrified. They're competing against fundamentally different production technology that strengthens as Tesla grows while their own advantages erode. Here's exactly why the Model 2 Senior lasts 250,000 miles while traditional cars fail at 150,000. It's physics, not marketing. When you eliminate 1,600 weld points from the frame, you remove 1,600 future failure zones. No welds means no rust points, no stress cracks, no joints that loosen over time. The car doesn't need to be more durable. It's built without the parts that cause failure in the first place. This changes everything. We're watching the automotive industry split into two categories: manufacturers still welding 400 parts together, and Tesla casting entire structures in 7 seconds. By 2027, when GM and Ford finally deploy their 30,000-ton presses, Tesla will have already produced over 2 million gigacast vehicles at costs competitors cannot match. The gap isn't closing, It's accelerating. The bigger question, what happens when millions of drivers realize a $15,000 EV outlasts any gas car they've owned? Does the transition happen faster than every prediction? If you want the answer, drop 250K in the comments with your thoughts on whether single-piece casting is the future. Hit that like button if this breakdown gave you clarity on where the industry is actually heading. Subscribe to Tesla Zone and turn on notifications because we're tracking every development in this manufacturing revolution as it unfolds. The end of gas cars isn't coming. It's already here,